Good morning.
Hi everyone, how's it going?
Hello. You're okay?
Hi, Rich. I'm good, yes. Just doing meeting today on my phone.
I think today it's only my team presenting anyway. Manasseh can't make the call, so I'm just gonna cover off what work she did.
Okay, sounds good.
Yeah,
Yeah,
she done the artificial neural network for the regression
amazing.
task. So
Yep,
we're gonna go
that's good.
through that. But yeah, Imran, have you got anything to share before we make a start? It's just only because I need to be able to share my screen and things like that. And I'll run through it as quick as I can and take questions.
That's a good idea since a weekday. Just one quick announcement. Last week, actually, I talked about it that I'm going to roll out evaluation. And as we did in part one, I deliberately waited for weeks. I wanted to make sure we are almost halfway done, which we are right now. So it's a new evaluation, which I'm posting the link on the chat. I encourage everyone to please, it's an anonymous survey, so please give your feedback over there. We will also send an announcement on that, so you can get the link from there as well. And try to get it done in a day or two. 2 days is fine. And this time I little bit make one change, although as in addition to regular questions, from last time I took some from which were not too relevant. I asked also last time that I'm going to send one evaluation for myself as well, because I noticed some of my decision have an impact on the participants in one way or the other. So some evaluation on that end as well for me to tailor my strategy if needed or decide my future course of action. So that's it from my side. I'll pass it down to Rich now to carry on.
Cool.
Giving you access. Thanks, everyone.
Share my screen. Okay. Can everyone see my screen? Yeah.
Yes.
So we, as my team, decided we'd take 3 approaches. Well, 4 technically, and the first one we decided to go for was to experiment with an artificial neural network. And Manasseh, she was the one who built the architecture, and she ran a baseline data set through, as well as the KNN imputed data set from the light GMB feature selection and the simple imputed one with the light GMB feature selection as well. Now, Manasseh can't make it today. She had an emergency, so I've uploaded her template file, and she's made quite reasonable notes. So I'll go in there and take a look at it. But if you need, I'm going to run through it quite basically here, but if you need to understand some of the decisions that she's made, it's probably better if you contact her. I mean, I only managed to take a look at this morning, and I found out that she wasn't able to make it. So I'm just going to try and do my best to run through it. So the first steps, what she did was basically she ran it on the raw data. So she didn't use any sort of EDA, insights or anything at all. She literally just took the raw data, she imputed it, got rid of the NAs, she scaled it, and then just fed it into the artificial neural network. And the artificial neural network architecture that she chose, she used a dropout layer, as you can see here. And what basically she had three layers in three like sort of hidden layers, and one input layer and one output layer. And the dropout, what dropout does is basically, she set it to 0.3 on the hidden layers, and on the output layer, she didn't put it on the output layer. She made a dropout layer, standalone right there, and it's 0.3 and 0.4. And what that does is basically, the 0.3 figure and the 0.4 figure are a probability figure, and every time it passes through the layers, it basically drops. That's the probability it'll drop a couple of neurons, and what that does is basically improve the generalization of the network. It forces it to learn a little bit harder. Activation function, she's used a ReLU, and on the output layer she used a linear. And she's added a note there explaining every single part of the architecture. So she ran it through, how many epochs was it? Where are we? Where's the epoch? Yeah, 20 epochs to start off with, but she also put a early stopping function on there. So if nothing changes in the neural network's learning rate, or its loss and its accuracy, basically, after 5 epochs, it would automatically stop because it's learned as much as it can. So it checks, 5 more layers and then says, we have, there hasn't been any progress in the model's learning. So we ran that, and we got 9 out. It stopped quite short, and we got to 9 epochs. And she used what's she done here? Yep. So she's used, she's predicted on the raw data, on the scaled X-test data, and she's calculated the mean absolute error, and she's put them into the metrics that we're going to use, which is the mean absolute error. And on the raw data, she's got 0.44, and the mean squared error for the raw data is 0.67. But as you can see, the performance of the model doesn't seem to be too convincing. The training loss just pretty much flat lines, and the validation loss is quite, it's got quite some variance to it. So the next step was to try the same approach on the feature engineered data. So this was, she first tried it on, do you remember the feature engineered data, the scale and encoded train? So it was the full data set that had just been scaled and encoded. She tried it on that, and we got a similar sort of view, but we managed to get she put it onto 50 epochs, but we managed to get to 28 on that one. And it seemed a little bit more, but the results of the model isn't too convincing, and I'll tell you a little bit more about that when we reach to the end of this particular part. She received, on this particular model, there was a 46 MA, for a mean absolute error, and MSE. So it didn't really improve, it actually lost some accuracy, but again, it's being overfitted and underfitted and whatnot, just because the way the architecture is being set up. Next was the KNN imputed data. She slightly edited the architecture in terms of how many neurons they're using in the particular layers, and she's reduced the layer by 1 as well. She still used the dropout with the same function, except the last dropout layer is 0.3. That's just trying to tune the hyperparameters. They're the kind of things that you need to tune to try and improve the model. So what she's done there is basically simplified it. The data set is much more simple, because obviously it's only got it had 3 features and 1 target feature. So she's made the model a bit more simple as well, to see if that makes any difference whatsoever. She reduced the epochs to 30, and she still had the early stopping, but she changed the patient's value to 10. and we got to 17 epochs on that one before it hit a brick wall. But again, as you can see, it's not very convincing whatsoever. The next attempt was on the simple imputed, and sorry, for the KNN imputed, as you can see, there's it's got worse again. The simple imputed, she pretty much kept the same architecture, but she's just increased the neurons to 90 in this particular round. Still has the dropout layer as 0.3, and we've got the patient still at 10. And on this one, we got the epochs up to 30. It completed it, so it actually did make some progress and was able to finish its training run. Again, though, it wasn't too convincing. Nothing really changed, and as you can see, the training and validation loss, were pretty much flat lines rather quickly. So, even though it seems that we're getting not too bad MA in context of our data, we know that the model wasn't really doing very well. It was overfitting, and that's the reason for that. It is that neural networks depend when you've the more fine, the more tuned to unstructured data, because they do have a sort of locality bias. So when you're using a neural network, a deep neural network, it's it does have that sort of locality bias, and tabular data doesn't necessarily have locality in term, like unstructured data does. So in terms of like images and sounds and stuff, you can compute the distance between various features where tabular data doesn't necessarily have that. So they underperform basically on these sorts of things. But there is, I've done a bit of research when I was speaking with Manasseh, what we could do to improve it. And there is a particular neural network called a TabNet, and a TabNet has been specifically designed to run on tabular data. So what you get when you're using neural network just on tabular data, the features that end up in the high dimensional space, they're not very dense and they're not very continuous. So it makes it difficult for a neural network to sort of extract, exploit that information and make valuable predictions. But the TabNet apparently, has a function within it, an activation function within it that is able to overcome that. So, please by all means go into this, download this notebook and mess around with it. Edit the architecture, change the dropout layers and things like that. But it might be an idea to, if we want to try more neural networks, it might be an idea to convert this particular architecture into a TabNet and see what that does. But ultimately, what Manasseh found was that her neural network for this particular task wasn't very good. But it was definitely time well spent, because we did learn something, and we do have options to improve it by using things such as TabNet. But it was also interesting to see, I'd heard of neural networks, especially deep ones with multiple layers, did have a bit of some problems with tabular data, simply because it doesn't have the data in tabular, it doesn't have any locality, and neural networks will be inherently biased towards locality. But it was good to see that in action, and it's a shame that it didn't work. But we do have it's a big learning curve, and we have much more room for improvements on it, and we can try different methods of neural network, especially the TabNet, which I'm gonna try in my own time, and if I can improve it, great. But it's definitely worth having a go. So the next part of it was that I would run my model selection template and figure out and run it through a number of different regression models. So what I've done there was, these are all the regression models. I put it through linear regression, ridge, LARS, passive aggressive regressors and things like that. But what I actually done was I found that the best performance every single time on every data set I tried it on were XGB boost and the random forest regressor. So what I've done basically is cut it down. And the data set I decided to use for this one is the KNN imputer. What Michael done a bit of research on our data, and he has basically built a model, and he actually analysed what was more effective in terms of imputation. Was it the simple imputer and the KNN imputer? And what Michael found was that the KNN imputer seemed to give our models, much more predictive power. It made the features that it did impute stronger. So what I did in this, I haven't run the simple imputer based on that sort of insight. I took the KNN imputer and data set, and I've ran it through there. And it's the light GMB feature selected data set. So we've got 3 features and 1 target variable. So what I did, and I've noticed a mistake in this. I'll show you in a moment. I just need to re-upload the notebook. So I used it on the 2 regressors, XGB Boost and the Random Forest regressor. And what I've done here is it pretty much pits the 2 regressors against each other, and it gives you the runtime, how long it took to run. And this was me error here. I used the wrong metrics just because I copied this over from a template that I'd previously run. But I'll show you in a moment. I've done it for the Random Forest as well, and I've made them changes. So as you can see here, what usually that would do would rank it by MAE and MSE as well. And it turns out that the Random Forest one is higher in terms of MAE than the regressor, even though they're both tree based, but the Random Forest performed a lot better. So the first thing I done was on the XG Boost was pretty much run it without any sort of hyperparameter tuning whatsoever, and brought back a metric, and the MA we received was 4.56. And I composed a graph of basically what the actual values were in the test set and the predicted values. So as you can see, it's not too bad, but there are very obvious sort of anomalies in terms of why is it predicting, such a very, high number when the actual value is down here. So obviously there's room for improvement there. What I've done here was get all the parameters that the default model has. So these are all your defaults, and based on that, I took a random selection of a couple of these hyperparameters and just input a number of different versions in a parameter grid. And so what I did there was use the grid search CV option from scikit-learn. And what this basically does is it takes the param grid and it tests your model on these parameters that you've defined. And then based on the MAE, based on the negative root mean squared error scoring, it gives you the best hyperparameters for that particular run. And then what I've done, I took these hyperparameters and I've input them to try it with, alone. So I've put fit the model to the train and test, the train data again, and then computed the score. So based on this particular set, it improved it by 0.3. Not massive, but it's still an improvement. So I knew I was on the right track. And again, you can see, you probably can't tell the human eye, but there's definitely some sort of improvements here. It's just be really hard to tell. So the next method I used was the random search. So I thought I'd try something a little bit different. Again, I took more hyperparameters this time, randomly selected them, and I've used a slightly different technique. So I'm basically looping through ranges between a couple of the values, just so, because what the randomized search does, it randomly selects hyperparameters rather than going through the whole grid. It does it at random. So I made sure that I had a lot of variance in these, so it could pick the best sort of it could pick a number of different combinations which were quite varied, and the iteration time I set as 100. So it pretty much tries it 100 times and takes 100 random samples and comes back with the best performing sample. And as you can see, this particular set seemed to be the best on this particular run. So I input them on the random search parameters, and it actually scores worse on that particular run. So my idea here was it scored worse because I've allowed the model to be I've increased the variance of hyperparameters. So maybe my thinking was there's too many cooks, if you know what I mean. There's too many options, so it has difficulty picking optimum one. So what I did in the next sort of run, and as you can see, it's flatlined again here, and anomalies are very high. So what I did, I defined it, tried it with the random search, but I was a bit more precise in what I allowed the machine to pick. And again, it spat out the optimum from that particular selection. And when I input it, it improved quite a bit, to be fair, from the previous run, 4.47. And as you can see here, the variance in prediction seems to be a little bit better from the particular selection of data that it has. And that at the moment was the best of what I've done with the XGBoost. The next part of it was the random forest. However, because it's a random forest, it's still, I've been trying to run it as fast as I can, but I'm still in the middle of processing it. But from initial findings, where is the first one? No, I don't think it's loaded, has it? It's still running. Is it this one? Well, what I've found, I don't know why it hasn't loaded, or I think it's just crashed out for some reason. The initial graph, so what the graphs that you see here on the random forest, the predicted values are actually much more in line with the actual values, so we don't have such a large spike here. So I think once I'm finished with the random forest, once I've understood all the parameters, and I'll try out a number of different things, I think the random forest one is probably the model that I'm going to take forward once I've tuned it, because even on the initial run, I don't know why it hasn't saved it, but on the initial run, it seems to have, like, even just a blank run, it seems to score much better than the XGBoost regressor. So I just need to finish this off and upload it, and please feel free to go into it and have a look yourself. But it's just because it's taken a lot of time to run. I haven't uploaded it, basically. But yeah, so that is Manasseh's work complete, and mine. I will complete this by the end of the day, but I think, as I say, the random forest is probably going to be our best model from what I know. I do believe, let me just stop sharing there. Michael has done some work. Is Michael here at the
I'm
moment?
here, yes.
Yeah, Michael's there. Michael's done some work. So I've had a look at what Michael's done, and he's done some fantastic work, but I'm not in the position to talk you through it. So Michael, would you be happy to talk through what you've done so far?
Absolutely. I can do that. Let me share my screen. Where is it? That one. Okay, is everyone seeing the notebook right now?
Yes.
Okay.
Yep.
So I took a slightly different approach. I am using a slightly different data set from
Michael, do you mind zooming in a little?
Sorry. Yeah, absolutely. Is that better?
Yes, much better. Thank you.
Okay, so I took a slightly different approach from what Rich was doing. I wanted to see what would happen using a slightly different data set. I wanted to try and create a set of features that was more directly intuitive. So I use a lot of I base a lot of things on stuff that Salman and Rich have both done previously, but I adapted significantly. So I dealt with the missing values in year, converted the year built into an age column, which is something that we did standard, which is kind of standard across the whole thing. Then I dropped essentially all of the temperature data that was, because it's fundamentally, it is present in the data inside of the cooling days and heating days features, which are essentially the only features I kept. So after removing all of these features, the features that ended up staying was state factor, facility type, floor area, Energy Star rating, cooling degree days, heating, site EUI, and then age, which we just created. This makes it so that the only feature that now needs to be imputed is now Energy Star rating, which has about 30-ish thousand data points that need to be imputed. Since it doesn't add that, rather than combining any of the facility types into smaller groups as we've done in previous notebooks, for this one, I just did a pandas get dummies, which one hot encoded both state factor and facility type. So we end up with 72 total features. I split into, prior to doing any imputation, I split the data into a training set, test set. For the first run, I just did a simple imputer just to see, how effective the, this data set essentially would be, which is this is the same that Salmon's like baseline data set uses. So we did use a simple imputer, scaled the data, and then did the transforms on the test and training, our X and Y's for our targets. And then I used Salmon put together a very nice, just essentially, set of models that you can run these all through. And use the same exact scoring system that he did. After running it through just the baseline version, random forest regressor comes out with the best root mean square error of 0.67 using scaled target value, which is a mean absolute error of 0.32, which is actually not a terrible performance. So it seems like this set of data that I use is relatively, it at least has some sort of value to it. Then looking at that, I wanted to determine what the effect of imputation was going to be. So I dropped all of the, I went back to the data set prior to imputation, and I removed all of the null values from the data set for Energy Star rating, which essentially just gives us a data set of like 48,000 values that we can now test on. I split again because we don't have to impute. All I did was scale the data. Once everything's been scaled, I ran everything through again. This greatly improved the accuracy of the model. So previously, our best RMSE was 0.67. Eliminating the imputed values, we significantly improved to 0.54, which goes to show that that we're losing accuracy in the model based on our imputation, is what that comparison shows. So next, I decided to implement KNN imputer. So I brought the data in again from before, split it, imputed it with a KNN imputer using 5 neighbors, and then ran it through all of the models again. Yet again, random forest comes out on top. But this time, with the KNN imputer, we get almost identical performance in our random forest model with the random forest regressor as when we're not doing any imputation at all, which shows that at the very least KNN imputation in this using this model is at least as accurate as the baseline data itself. I have not, I did not get a chance today. I was going to be doing, I didn't get a chance to tune either the imputer or the KNN model itself. But I think that there is some additional accuracy that can be gained further by actually hyperparameter tuning these models. I think that random forest, at least for this version of the data set, is probably the best bet. But I think the important piece coming out of this is that I think that I don't know, regardless of any data set, I think that one of the things that we need to, focus on is making sure that however we're imputing, because there are so many missing values in Energy Star rating, we need to make sure that we are using the best imputation for that missing data, because it is such an important part to the accuracy of the models themselves. Even when we were doing our data initial findings, one of the things that we saw was that there is some correlation directly between Energy Star rating and site EUI. So I think that this shows that there's a lot to be gained from coming out with this, and there might be other methods that we could use. I've only done a couple of other things for imputation, but it might even be worth trying to actually use a model to generate the missing Energy Star ratings, and then feeding that data back into another model to eventually compute the site EUI. Does anyone have any questions?
Yeah, we've that was a good point raised. I think that I set the KNN imputer to 5 neighbors, just because it's a good place to start, and I don't think anyone has altered that since. So I think it would be interesting to see if we could, either tighten it up to maybe 3 or go higher and just see how that affects model performance. It is a good insight, and I think it'll be an interesting avenue to explore if anyone's got the time to do that. Sorry, Salman, I cut you off then.
Yes, it's okay. It is amazing. One thing you can try, Michael, is so far the pipelines that we created, we did not include the outlier removal part. If you means whatever data you are or pipeline you are generating, if you kind of like go back and remove the outliers and run the same models all over again, I believe your model results would improve, because we did not run in the pipelines that we have right now. We did not run the outlier detection or outlier removal thing. So just removing the outlier would improve the results, I believe. And other than that, the imputation, yes, that's what I wanted to say. With Rich said that nearest neighbor that he picked was 5. We can play with that number as well. And even what we can do is means I just did simple imputation, or standardization. So standardization, we can include some hard standardization. For example, like there is a quantile transformer which I will be implementing. If you want, you can try. What it does is basically it forces everything to be it hard forces everything to be standardized, which means one of the input that it takes is basically that what kind of a transformation or what kind of a output distribution you want. You just give it to that, it will automatically does all the things inside it in order to convert it into a normal distribution. So we can convert all of them into normal distribution, then apply the maybe standard scaling or standardize it using z-score or something, so that mean is 0, and that can also maybe improve the result. These are few tweaks we can do in the data, I think. I see you got a very good R-square score, because there's I can see that there is 70%, 0.70, which is a very good R-square score. That means it is grabbing a lot, around 70% variance in the data. That means it's amazing. The baseline model that I used, it was grabbing most probably I think 49 or 50% variance. That was the best I was getting. So 70%, I think you already have improved the model performance by doing these things. So I think mean absolute error, you have already brought that down as well, because I was getting 0.38, I think, and this is 0.27. So already the model has been updated, which is really good. I think those few little tweaks can improve the result way better than this. Yeah.
I certainly hopefully I'll have some time to give some other things a try, and I do think there's definitely hyperparameter tuning that can be done, and I do think that there is some additional data cleaning. This is the only data that really had any like outlier removal was fundamentally the age category. Everything else that was kept. So this is about as I guess dirty as the data gets. So I think there's definitely some space to move up from here.
Yeah, that's right. That was really good, Michael. I really like it.
Definitely. Other than that, Masood, you tried the Automl. Have you got anything to present today?
Yes, I got some results. I don't know, maybe I can share it.
I think we should rejoin the meeting.
Oh yeah, actually, yeah, we've only got 4 minutes left. Let's rejoin and then
okay.
Okay, go ahead, Mansoor. I've given you access.
Great. Thank you.
Okay.
Can you see my screen?
Yes.
Okay, great. So I use Azure AutoML to kind of find, based on a raw data set, also a transform data set as a KNN, to see what algorithm is working best for our data set. Just start from first. This is Azure, Microsoft Azure.
Azure ML. I like Azure ML.
Yeah, it's great actually. It's the service for Azure Machine Learning. I already installed it, launch it. So, okay. Then I create the compute instance. The kind of compute instance, the workspace, I can run all my model. And computer cluster also for training part. I kind of remove it just now. I just stop it because my job is done. So let me run one of them, maybe for raw data set. And start. After that, after creating the workspace, working with ML, I import the data set. I import raw data set. That was our just trained data set. Then we had the AutoML KNN data set. After transformation, also simple impute data set. Just wanted to see for each one of these data sets, which algorithm work best. Then went to AutoML, create the new job. Here, it's so easy, just select the data set that you want. For example, here, AutoML raw data set, select, next. To put that new one, create new name, just point here, AutoML raw. The target column that you have, in case of my raw data set, site EY is my target column. Choose your the cluster, choose the workspace that you want to work. Let me start. Still, you need more time. Let me, I hope it works. As you see, raw data climate is kind of creating the workspace to create the model. Okay. So after this, go to the next page, and then you give some special feature. So you tell the model, AutoML model, go through all the missing value. They take all the outlier. Then do the linear all algorithm. If it's about go through the 40, 50 algorithm, mostly ensemble modeling, ANN, and all possible algorithm for regression. Then you choose the metric that you want. For me, I choose the R square. So for R square, I go 5 hours, try different modeling and give me the best possible. Here you take time, I will go just show you the job. Let me, so I create for raw AutoML. As you see, job 1 completed. It took me about 5 hours. I can give it time. You can give, if you don't have time or you don't have enough cluster or the credit for your Azure, you can choose the 30 minutes. Also, I choose the metric of R square about 80%. Go inside. Go to the model. As you see here, based on what I gave, the voting ensemble is the best possible model for raw data set. I got about 0.22% R square for this. And then we have, also want to explain the voting ensemble. Voting ensemble is we go through different ensemble modeling, XG boosting, random forest, and bagging, and give you the average of all of this modeling. So a stagger ensemble and XG boosting, this is all from go up R square to the last one can be XG boosting regressor. Also, as you see here, each one of them, for you do different kind of normalization and standardization for each one of these models. So try max, absolute scalar, standard scalar, sparse normalization, normalizer. So try different kind of transformer with different algorithm and give you the best result. Okay, for us, voting ensemble is the best result we have. Go inside. Then let me go on here. This is the metric they have. Mean absolute error, mean absolute percentage. You can choose what other error that we have. Even residual. As you see, this is residual. This is residual histogram, kind of predicted value compared to true value, and so many more. This is a Spearman correlation. For Spearman correlation, this is great, 0.76. Then for explanation part, you can choose the most important variable, affect your model. For our case, if I just want to show 4 main features, the energy star rating, facility type, building class, and average temperature January is mostly affect our model. You can change it to more, maybe 10 feature. And this 10 feature, as you see, again, these are top 10 main feature. I'm just talking about the raw data set. These are top main feature affecting your model. Also have here to aggregate feature importance. This again, top main important independent variable affecting our model. This is the model performance. Also, I did similar thing for the simple impute. Unfortunately, didn't work. As we see, it failed last night. So I can't try to do it again, but I did on the KNN data set too. So for KNN, if you remember, we had 3 main variable, and one is a target variable. Go to model. Again, for KNN, I just run the model for 30 minutes. For KNN, I have to do it more for 5 or 6 hours to find. Definitely, we can improve the model. For now, we have kind of about 40% R-square. I will do it for 5 hours. Again, for voting ensemble, go inside the metrics. Let me do the experiment correlation too. About 0.60. It seems for less training time, we have kind of less accurate, less R-square compared to raw data set. Maybe because we remove a lot of missing values, a column, and we have just 3 variable. I'm going to show you the raw. Maybe I can't show here. No. Let me show the explanation. As you remember, for the KNN auto simple imputer, we are just after PCA, we did just select 3 most important independent variable and just 1 target variable, and we had about 62,000 row, a combined train, test, and validation data set. As we expect, the column 1 most important, column 2, and column 3 more important, column 3. So for both cases, it seems in my results show voting ensemble is the best model in case of our data set. I'm going to do coding part now because I know which one is the best. And after voting ensemble, it was XG boosting for my case. I can do the modeling part in the coding part in the Python using voting ensemble to see what R-square I can get in best case. That is my result, actually. Any question?
Does this process convert the categoricals into factors or something? Like one-hot encoding?
Would you please repeat?
Does this process, the AutoML process, consider getting one-hot encoded categorical variables?
No, actually, I hope it works now. I see I can do it now. Let's create the AutoML now. I will show you. Just again, choose the AutoML. Next. That's so interesting thing to do at AutoML. Raw, as I said. Target column. Instant cluster because we run it. Now is running. Okay. So now we have the workspace we need to train our model. Next. Now you can choose here what kind of algorithm you need. Is classification, regression, time series, NLP, or computer vision. So here, as you see, because our target variable is continuous, we choose just regression. If it's binary, you can use classification. Also have some computer vision data set. I want to use this. This is a new service that Azure add. Actually, didn't have it until 2 months ago. So you choose a regression to go here and view additional configuration setting. Okay, still explain best model, use all support model. Okay, you can the primary metrics that you need. You can tell, okay, I need R-square, I need experiment correlation or normalized mean absolute error. It gives you everything, but for now you can choose, for example, R-square. List of all the modeling you go through. This is all the modeling that we have here, and our model, our AutoML, go through this kind of modeling. Also, we can here block model. We can say, okay, don't go to decision tree. In this case, you can save some time or don't go through the last class. Then you can put exit criterion. You can tell, okay, please go just 0.30 minute, 15 minutes as a half hour. It means 30 minutes to the training. And the metric threshold for me is 0.6, it means 60% R square. Then save it. Then view the featureization part, do everything for you. Do the missing handle the missing value, handle the outlier. Also, if you have some problem, you can change it, the feature type that you have. And here you just put all auto. So even do the hot encoding for you, label encoding for you. It's amazing, I think. Can save so much time to find the best model. Then put next and start. Then again here, validation type. I can tell, okay, do it for me, K for validation. Do train validation split, for example. And my validation is just 20%, and just finish. I'm going to be a stop. You go about 30 minutes and give you the best result.
Superb.
Yeah, I think it's amazing. It saves so much time.
For sure.
There's another option, hyperdrive. If I can have time, I will show you. That is mostly coding, but go through all the hyperparameter again. But AutoML normally is faster. And normally
I'm not very familiar with Microsoft Azure Learning Studio. Can you now, if you build a model in it, can you extract the underlying code from it?
No, that's the problem. If it was
Okay,
it was amazing.
Yeah.
Yeah. I was thinking about that, especially I don't know.
Well, I'll message Bill Gates on Twitter and tell him
tell
him to put that feature in.
I think they're doing
but
that. Actually. They try to do that, but you see, let me go to job. If I just go here,
go to the outputs and check out the outputs.
The output. Let me output here. Give you some of the coding here. This
So
one.
go to the driver.py.
This is give you some coding. It seems, but it's kind of different with the Python a little. Yes. We can have a Python R stuff, but a little coding is more. You see, transform the data here, but I don't know if you can run it through the Jupyter Notebook or not. Really, I didn't try it.
This will not run on Jupyter Notebook.
Oh yeah, that's what I'm thinking. Yeah, but this is coding all you need. You see, it's all the transformation part, all the coding part. Also, all the child job, step by step. The last one, for example, is this one. It's AutoML. Interesting thing about the metric. They give you all the possible metrics that you need.
So I have a question. Means if you run AutoML like this and you figured out that one of the model, like for example, voting Ensemble is doing really good, how can we deploy it somewhere?
Actually, here you see the option here. Deploy to real time or web service. Then choose the name.
Yes.
And okay, and easy to deploy.
Oh,
so
okay.
Yeah.
That's great.
Yeah.
Do you have the option to do time series analysis also?
Yeah, I remember that I show you the classification, regression, time series. Actually, they're all adding the new thing. NLP and computer vision they just added last month. We had a time series regression classification until last month, but Microsoft added the NLP and computer vision just recently.
Yes. So I worked on this tool a little bit, and previously I worked on Azure ML. What I found out was in some cases things like quantile regression, where you are predicting a prediction interval rather than a confidence interval. So those things are still not included in the AutoML. I think they will be included in future. It is there in the design.
Just let me show you I think you are familiar with the designer. Let me show you the designer. That's the amazing thing too. Let me the designer. the designer, look at this. You have so many examples. So here we are just coming here to learn. So you can go to, let me go to regression. Everything kind of drag and drop. Put your data set in AutoML price, or you can put whatever data set you have. Then mention, go to the selected column that you need, clean my missing value, split my data set, then train my model based on linear regression, score it and evaluate it. And at the end, you can go here, it's not still run, but see the results, see the R square value, whatever you have. It's so much helpful. Also, you can deploy the model exactly here. You have so many optional algorithms in the designer.
Yes.
I think maybe you have about, I think 40 to 50 different algorithms in designer, from computer vision, recommendation system, 15 or 20 classification algorithm. I think can be so helpful. I think so much time.
Your custom code, right? You can include your custom code also.
Yeah. You can choose R coding and Python coding. You can add your coding to the drag and drop too. So you can write code. Also, you can just do permutation feature import and here. This is the code. This is the drag and drop. Just you add your column or data set here at the top and done. Publish it. Submit all the column that we have, all the things that we add here. To give you 10, 20, all the feature important. Also, another is custom vision. Please go and look at the custom vision. It's an amazing thing. In case of computer vision.
That is amazing. Masood and Roy, can you guys recommend any tutorial which can break it down into means how to get started with that? Because I understand what you are doing here, but how to get there in the first place? That is something. If you can guide us to any tutorial. Because I understand what you are doing, which means if I can get to that point, I can do what you are doing. But how to get to that point?
Actually, there is a good course in Coursera.
Okay.
I can send it. Maybe I don't know if
Yes,
I can send it
I
via
would
Slack.
really appreciate if
I
you
don't know
can
which
just
channel I can
Yes,
send it,
please.
but yeah.
Generally, I have also found that the documentation, Azure documentation,
amazing. Yeah.
Very, very good. Like there are actual buttons where you can click and it will launch the things talked about in the documentation.
Yeah.
Okay, that's amazing. That's amazing. Thank you.
Yeah, that's a Microsoft Learn, they call it. Yes.
Do you mind discussing with each other and then maybe share 3-4 links which you guys are talking about, which Salman was asking?
Yeah.
On our
which
chat.
Which channel you want me to add the course and the Microsoft Learn? I don't know. I can add it in the model deployment if you want channel. I can add the date.
Yes.
Okay.
Anywhere, maybe in whichever Slack channel you want to share, just share.
Okay.
Yeah.
Sure.
That would be really appreciated. Yeah. Thank you.
And is it as a AWS that we need to have like a account and we have a limited minutes or storage?
For AWS, I did the, I don't know, you guys are familiar with the jump start. Go and look the jump start. It's kind of similar, but it's better on the NLP and computer vision, I believe. Jump start, you have about 20
Can you write
transferring
it down?
options.
What is it? Jump start?
Jump start, yes.
I think the question that you asked, Ina, is it like AWS? You need to have an account and I think
yeah, both
yeah.
of them. Even
I mean,
Azure.
for paying.
Yeah. You have some free hours or free this thing, and then it's
for all the cloud.
Yes.
For all the cloud, you have $300 free credit, right? And after that, you can make a subscription account under which you will be charged.
Yeah, pay per use. Yes.
But just watch out. You have to always stop the
instances and everything. Yeah.
Compute cluster. I charged several times AWS, but I'm lucky I got the funding from Microsoft last fall actually. That's why I have enough funding, so I can use it.
Sweet. That would be great if you guys just send it on. I think support channel might be appropriate for
Support,
this.
sure.
Yes,
Okay.
that would be helpful.
Yeah, Roy, if you also can have a good resource, please send the link.
Yes.
Sure.
For Azure.
Thanks. Good job, everyone. Today, thoroughly loved it. Actually, going to rewatch this video. And anything else you guys have to cover?
No, I don't believe there is. The only other thing I need to do is update my random forest notebook once it's run, and then once the other team presentations go ahead, we can discuss what pieces of work we can take forward to the deployments. But I think what we've done some great work at the moment, and I think we've really progressed as a team. From the raw data to where we're at now. It's been quite the journey, to be honest, and it's good that we've got a number of different ideas. As we've split it into teams, we've all come together with different ideas, and I think that's the best way to do it, really. And I'm quite happy with my team specifically what we've done and what we've produced so far.
No, very well job. Very nice job for sure.
Yeah, that's amazing. Yeah.
So here's now. I just want to know, Rich. So how much more it will take your time? So you remember on a Teams leads its team which we had last Saturday. That was ours. How much time do we really need? Do you guys really have that much more? I don't think so. Like more content that we need to have a meeting on Friday? No, right?
Yeah, exactly. No, we don't have much to do. I just need to just correct a couple of errors in some notebooks. That's pretty much it. Okay,
good. So based on that, coming Sunday, team 2 and 3, I believe on the list, I guess it's Salman and Royce's team. They will be the one. It will be 45 minutes. Try to plan it out to just get it done 45 minutes each. So at least an hour and a half we can get it done ideally Sunday.
That's good.
And so that's we will be shooting this Sunday. And all the leads and co-leads are encouraged to please coordinate with each other because you all have done very good quality work. I'm sure there'll be lots of reference links as well. So if you guys can each lead co-lead compile all their links, whichever they have used, and then give it to Komal. So at least she can put it in her final list too for all the participants.
They can directly put it in the Excel too, Imran. I shared
or
the Excel.
Whatever.
Yeah, they can directly do that. Yeah. But if they need help, they can approach them.
So maybe in Excel, if you can, maybe, I don't know if you've created the separate sections for each lead. So maybe they can post it over there with topic wise. That can be helpful too.
Yeah, it's a common Excel. So I'm not sure if you really want to bring in the team aspect here. They can just keep on copy pasting topic wise links.
Yes. I'll also take a look at that. Okay, good. And yes, that's
Imran, one thing regarding the final presentation, can we run through the timelines for all the teams once?
For the final, okay.
So like we were discussing, first team is going to present on the 27th. Is this correct assumption? Next.
Yes.
So that has to be with all the deployments and the final presentation that we are planning to do per team, right?
So here's the thing. Okay, you guys cannot see my screen, right? Let's see the calendar very quick. We are supposed to end with this model development and evaluation on 27th. So this Sunday there will be team 2 and 3 will be presenting. Team 4 will present next Wednesday, which is 27th. After that, we will have one last week, which is our final week. So in that one, we'll have to see. I guess in that particular week, I guess we will need 3 meetings rather than 2. So that will be on Friday, Sunday, and Wednesday.
Yeah. So 29th.
Yes.
So first team will be 29th, and next 2 would be on 31st, and the last one on 3rd.
Yep. Does it sound good to everyone? That's how we decided in last one, right?
Yeah.
Yes. So that's what it is. Okay, guys. Nothing else on my agenda, and that I'll see you guys on Sunday. Rich.
Yep.
And actually, just a question to Rich. Do you have like 2 minutes after this meeting?
Yeah, of course, yeah.
Okay,
yep.
So everybody can leave. Only Rich and Salman can stay, if they can. Hey guys, so it was just a random thought, and we don't know if that's right or wrong, but we wanted to discuss with you guys. We are thinking that, assuming, I don't know if Rich, did you see on Team Salman's channel? I think that participant named Divya.
Sunita.
What's her name? I don't know her name.
I think Sunita.
Sorry. Yes, thank
Sunita.
you. Thanks for correcting me. She sent one nice Excel with all 10 models, and basically she got all results and compiled nicely in one concise form, right? We were thinking
Sunita, I think, yeah.
Thanks for correcting, my bad. So we were thinking, how about like we set some basic requirement, like whoever, or feel free to give your inputs, whoever does those 11 models and just compile, let's give us one picture like they have done it. Maybe we can create one small session, maybe half an hour, like a formal session, when we say these are the actual people who have done it, and then maybe we can do on LinkedIn, like formally each other go and just endorse, because in the end of the day, we all are trying to go in within the company promotion or the wherever we want. I think it will give a boost as like in a formal way. Otherwise, in informal way, I'm not sure how actively people are doing that. But feel free to share an idea. It's just a random idea Komal and I was discussing, so we are not sure if you really want to do that or not. So give your inputs here, please.
Yeah, no, I think that's a good idea. I think what me and Salman, I've spoke about it before, and like we have connected with a lot of people from our lead, our task group on LinkedIn, and I think during the end of it, I certainly will be reviewing and giving recommendations to people who've I've worked with and have been on my team, and I've done some good work. So I'll be leaving, like, you can leave like a recommendation on someone's LinkedIn. It's just like a paragraph or two of free text. I'll be definitely doing that. But I think posting things like from the chapter page about maybe with certain examples of the work we've done, and tagging the people in who've completed that work would also be a good idea, and it just gets their name out there, and people can directly see what they've contributed to our particular project. So I do like things like that, and I think maybe at the end of our time we have a little meeting about what we can do and to help each other in the industry, like leaving recommendations, like tagging each other in work and things like that, and saying, because I done one for Salman the other day. I wrote something about data leakage and then put, Salman has written this beautiful example of code.
Thank you so much.
Yeah, so it's little things like that, and it boosts not only your name gets recognized, but it adds a lot of credibility as well. So I think we should have like a roundup meeting and discuss them sorts of things, what we can do for each other. Definitely.
It's definitely a great mindset. Thanks for sharing. I'm glad you have such a good mindset, and I know Salman also have similar kind of thoughts, and I also have some plans for what I have to do for you guys. You guys definitely have done a great job so far, so you guys will find out in a few days what I have planned. So how are we gonna execute this thing if we really want to do? I know it's on individual basis. How are we gonna make sure that those are some, like, do we really need one meeting, like when they show those models, like we acknowledge those? How are we gonna do that, or just like after once project end we just go over on and do that?
I think what everybody is doing, we should put together. I think it's a good idea what Sunita came up with. I was really happy to see that, because all the models kind of like giving you the results in one single table, which means it can summarize what exactly we have tried and what are the results we got from every single model, and it is a very compact version of it. So I think every team should be targeting to come up with a table which can summarize all the results, because I think in terms of presentations it would be quick. You don't have to go to the code, because right now we are going through the code. Today Rich's team went through the coding part already, so which means in the final meeting they don't have to go through the coding part. They can just talk about what strategies they tried and what results they got from each strategy. Similarly with my team, similarly with Roy's team, and similarly with the Max team. So I think this way way, the final presentation would be pretty quick. Means we all can present in one single meeting, and just 5 or 10 minutes maximum for per team, and we can summarize. We tried this, and we got this results. So they tried this, and they got this results, and so on. So I think that's a good idea in terms of recommendation and everything. In the first part, I have already done that for everyone. Means anyone who was means I have already kind of like endorsed them for the skills that they have shown, expressed, or something. Means I have done for anyone who has kind of like given some any input. Means I have done it for Rich. I have not done for you, Imran, yet. But
No,
Rich,
that is fine.
Komal,
Yeah, for me also, you've done it.
Vandana,
Yeah, thanks.
yes, Vandana, Varun, Tim, Mac. So anybody who is on my LinkedIn, I have already done that. So and the recommendation is something which I told them that I would be doing it by the end of the second part, because recommendation is something which means I want to be a fair recommendation. It's not like just handing them to the recommendation. Means if I'm working, I should be deserving it. Otherwise, there's no point getting the recommendation. So the same thing I would be doing for the other people as well. Yeah.
Yep, so that's good. So I guess you guys have already have that in mind. Okay, that's I guess that's the notion I'm getting right now.
Yes, we are already doing that. Means yeah.
So to make it more formal, because since you guys are doing it, I'm not sure if everybody has thought of that good idea. So maybe if you roll it out, so at least there will be, I think we have 20 people, so rather than just 4 or 5 people. I don't know right now how people are. So that was just a random thing Komal and I was discussing. Maybe we can. Do you have anything to add, Komal? I don't know.
Yeah. So just to reiterate, so Imran was suggesting that we ask everybody to go through those, the 10 pipelines and run the models that Salman has created and present us with that Excel. But do we want to show this as a requirement, and only if you show me this Excel, I would recommend or endorse for you? Do we want to present it like this, or we just want to say it as a suggestion? Yeah, so we just want to give it as a suggestion for any beginners. It will be best that if you could run through this, you'll give a very fair idea of overall models and everything, and add on to your learning. I think we should present it like this rather than as a requirement for getting endorsed. And like Salman and Rich said, maybe, and Imran was suggesting for this meeting too, we can have a 30 minutes meeting to present the ideas of how can we recommend each other in what all forms, doing endorsements or whatever, that we can discuss overall. And also, if needed, if people wanted, we can have a central place where we can share all the LinkedIn profiles for people, and people can connect with each other and endorse if they wish to.
Yep, that's a good idea, because not everybody is connected with me on LinkedIn, so I don't know their LinkedIn. So I think it's a good idea to maybe set up an Excel file, ask everyone to come and put their LinkedIn link, so that
it's like people want to do it. Maybe sometimes they don't remember that they have to do this also. It's like a reminder to them that make use of this opportunity where we all are meeting and make connections.
Yes. That's a good idea. Yeah.
So thanks, Komal. You break it down much better. I like that.
I know I saw you're giving good ideas, but somewhere you feel reluctant that am I doing too much? Am I doing less?
Yeah, I get.
I see that.
Thank you. Yeah, you got it right, because I just don't know. Maybe there's a lot I'm asking maybe. But I was in the end also with leads as well. I think there will get more limelights, at least 20-25 people. I think it's a good booster, I guess, in that sense as well. So that's what I was thinking. Okay, guys. So that was just a random thought. Also, since we all are doing it, I don't know why am I out from that recommendation, Salman?
No, we will. Wait, we will. We should and we will.
So means I will do it definitely. Means
I'm just kidding.
Yes.
I haven't. Yeah. Sorry. Let's do that Excel thing, and we'll go from there. Okay. Thanks, guys.
Cool. No worries.
Take care.
Have a good day, and I'll see you Sunday.
See you on Sunday. Bye-bye.
See you Sunday. Have a good one. Bye-bye.
Bye.